Look, this guy, this guy made that. You buy that used, you rent that, and that's a party tent. I don't know that he's got 400,000 or 500,000 into that. And this guy's got about 1.5 million. The nice thing about this one, it's all new equipment, and it's all automated, level control, PLC driven, everything's cool. So that 700 to 1.5, these treat about 200 gallons a minute, or 288,000 gallons of water a day. This is the process. Again, chemical mixing. This is my lab. This is another lab support function that we do. This is the kind of what is needed for reuse. They need to have frac fluids that can work in more stressed waters. They need detailed water analyses. They need fluid design performance considerations. They need scale modeling determinations, ICP, friction loops, state of the art for the industry. Again, getting technical, don't want to bore you. Geochemical modeling to make sure they're not going to foul their sand filter. You do an analysis of the water. You use predictive indices that are readily available, and you can prove that their water is going to be safe and effective for reuse. Typical microbiological evaluations, sulfate reproducers, acid producers, total aerobic bacteria. You don't want slime. You've got a sand filter down there, guys. You don't want that sand filter to get plugged up so that gas can't flow to wellhead. So you don't want scale, you don't want deposits, you don't want that bacteria. It's water treatment 101. Take those impurities out that form them, feed chemicals that prevent them. Pretty simple stuff. All right, so the correct frac fluid chemistry, iron and scale control, compatibility, that means it's got to play nice down in the formation. This is some things that can go wrong. If you don't know what you're doing, you can have your fluid design interfere with your water quality. These are the types of way you can place the sand, which is called proppant. You can use linear gels, cross-link gels, slick water systems, and things like that. These are the types of chemicals. Everyone, what are they pumping underground? Really not that harmful, pretty innocuous. Friction reducers to reduce the amount of pressure necessary to place the water in sand. Surfactants, which is a fancy name for soap, or microemulsions that reduces the surface tension, allows more water to come out of formation, more gas. Don't want iron, don't want bacteria, you don't want scale, you don't want clay fines. So these are typical slick water chemicals that are used on the gas fracturing process. These are the things. They need to be thermally stable, they need to be environmentally responsible, safe to handle, non-persistent in the environment, soluble in brines because you got a lot of chlorides downhole. This is the lower 48. These are the shale gas basins. Here we are with the Marcellus. Here's that Utica that I told you that's underneath. That's going to be the next play. Making a whole lot of money down here in the Barnett. Up here in the Williston Basin, you got a lot in Colorado. You got East Texas and West Texas, Louisiana. Which is the Bossier City, which is the Haynesville play. Again, same technology, just different parts of the country. My issues are if our goofy-ass government makes these regulations so difficult, these people are going to take all their toys and go here, 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 and here. They don't care where they make their money. If the Pennsylvanians are going to be stupid, not let them, they'll move. I don't see that happening because there's just too many billions and billions and billions with a B, probably T, trillions with a T. There's just too much money involved. That's the biggest rock here, guys, and here's your population. Why isn't this going to develop? When you heard about the Barnett, you can put 10 Barnetts in the Marcellus. This is what happens as water quality changes over time. This is sequential flowback analyses. This is, I'm going to write 3 SPE papers on this, understanding what's coming because each county is different. Understanding what's coming back to you over time really solves 3 problems. How do I treat it? What's in it to get the green tree huggers off your ass? And what do I need to feed in my fluid design so that I'm safe and effective on my next project? These are just different things, tools for predicting the variability. This is iron coming back at various stages of the flowback. So if I'm an operator, I'm going to feed chemicals to remove the iron, but also chemicals to prevent it from plugging my sand filter up. Chelants, chemicals, acids, and things that keeps it soluble, keeps it flowing out of the sand and not being left behind as a particulate in your sand filter, just like a swimming pool.